I think my screen is visible, right? So yeah, yesterday what we have seen is all about the introduction parts. What are the different projects we are doing in this course, and what are the different course content it is there, and prerequisites we have seen. The only prerequisite from the yesterday's document we can see that is AWS account, right? So all these three things we have seen yesterday, right? So today what we are moving uh, with our actual syllabus actually. Okay, so what if you have, if anyone has missed yesterday's class, okay, so your recording will be available in the YouTube channel of DurgaSoft. So you can visit that DurgaSoft channel and you can view the recording there, right? So yeah, that's the thing actually. And today we are moving towards the AWS Jenkins, Docker, and Kubernetes actual syllabus actually. Uh, yeah, now this is the course of AWS Jenkins, Docker, and Kubernetes, as you already know. And yesterday we performed all these three things: tutor introduction, general introduction, and the course introduction. Okay, so yeah, that's the thing actually. Today, this is our agenda actually. What is DevOps? What is an application? Okay, what is SDLC? What is server? What is physical server? What is Docker and Kubernetes? Where does Docker and Kubernetes fits in software release process actually? This is our agenda for today. Okay, now let's move one by one actually. Now, what is DevOps? DevOps is a combination of development and operations. Development does not mean it's an application development in DevOps, but it is a uh, uh, it is like developing scripts in order to automate the process actually. Okay, so you might have doing some process regularly, daily. Okay, so you need to automate that process using some scripts, whether it might be the Groovy, or whether it might be the Python, or whether it might be a shell script. Okay, or whether it might be the Terraform for infrastructure management. So developing some script in order to automate the uh what is that, uh daily working activities actually. Okay, that's under development actually. In development, DevOps people also expects uh some of the functionality you should know as part of the development in DevOps actually. Okay, so now what is ops? Ops means operations. Okay, so operations is something like a maintenance. Okay, maintaining the infrastructure. Infrastructure means maintaining the servers and maintaining all those things. Maintaining the application releases. Okay, you need to regularly update the applications on the servers whenever there is a new version of the application is being developed, right? So such kind of maintenance will be there as part of the operations. Okay, you need to regularly provide the support. Okay, something like that. Okay, okay. The DevOps consists of, like, DevOps is a process, like it's a methodology, okay, which contains many tools actually, which is a combination of which we can achieve. DevOps can be the methodology we can be achieved with the many tools. So these are the heavy tools. Many tools I have put as part of this slide actually. You can see that very clearly. Okay, out of these tools, as you already know, we are moving, we will be learning AWS, Docker, Kubernetes, and Jenkins. Okay, the four different tools that we'll be learning as part of this tools actually. Okay, so that's a DevOps, and what is development and what is operations. Okay, so now what is an application? Okay, application is simply nothing but a website. Okay, it's a website where we are going to interact with it. Okay, like you will be interacting with many applications in real world, right? So it's like Redbus or the Amazon.in it's an application, right? It's a web application. Okay, so its application is nothing but a with which we can interact with that application, and we can perform some activities. Okay, so that's an application. So why we are talking about this? Because Docker and Kubernetes comes in this place actually. Okay, so deploying the applications. Okay, so that's the thing. Okay, now what is SDLC? SDLC is a methodology that is followed in order to develop this application actually. Okay, SDLC is a methodology that the industry follows in order to develop this methodology. I know there are many other methodologies, and the latest methodology is also is there, but yeah, SDLC is the oldest methodology, that's I know. But yeah, I have put this slide actually. Okay, as part of this SDLC, software development lifecycle. Okay, so there are multiple stages that are available. Okay, so analysis phase. Okay, in this phase, what the people does, they collect the requirements. Okay, how much people are needed in order to develop this software, something like that. All the requirements were being collected in the requirements phase actually. Okay, once the requirements phase is been completed, the design phase, in the design phase, what the people will do is they will be performing the system design, or UI UX designer will be there, and they will be designing the application actually. Okay, so designing means, suppose you have a web page. Okay, so you need to enter the login details, username and password, right? So where that username and password fields should be displayed on the web page, whether it should be on the top of the web page or whether it should be on the bottom of the web page. So that is designed in the design phase. Okay, that's a UI UX design actually. And we have design patterns. Okay, so we have two types of designs actually, high level design and low level design. So all this design will be happen in the design phase actually. Okay, once the design phase has been completed, then people the design that is developed in the design phase will be given to the development phase. The people in the development phase will be choosing one of the programming languages, whether it might be the Java, whether it might be the any of the programming language. Okay, so they will be developing the applications actually. Okay, front end UI UX designer, the design which is given by the UI UX designer will be used by the front end developers to develop the UI. Okay, user interface, and the backend developers also will be involved in this development phase, and which will be who will be developing the APIs. Okay, so that's what backend developer does. And the backend developers also write the test cases, unit test cases, in order to perform unit testing actually. Okay, so in the development phase, the development is been happening will be happened from the design, and test cases will be written by the developers actually, unit test cases. Okay, it's a test cases means unit test cases, I mean. Okay, these are the things that will be happening in the development phase. Once the developing has been completed, the software which is developed in the development phase will be perform some testing. Okay, the testing means like they will performing different testing, whether it might be the regression or stress testing, or whatever testing it is. There will be some tools in order to perform this testing. Okay, so like Selenium and all the different tools will be there in order to perform this testing, and they'll be using the tools and perform testing on the developed software. Once the testing has been completed, deployment phase. Okay, so once the testing has been completed, in order to access this application from our browsers, you need to deploy that application, right? So somewhere you need to put that application so that people in all over the world can able to access that application. Okay, you need to deploy that application. Okay, in the deployment phase, people deploys the application actually. Okay, so once the deployment has been completed, maintenance phase. What is maintenance? Again, maintaining the applications, releasing regular software updates, all these things comes under the maintenance phase. Okay, so here where our Docker and Kubernetes comes into picture is at the deployment phase actually. Okay, in the deployment phase, our Docker and Kubernetes comes into picture, and the way we are going to deploy our applications on the servers is using is using Docker and Kubernetes in the deployment phase actually. Okay, these are 6 phases of SDLC process, and our Docker and Kubernetes fits in this deployment phase of this SDLC process actually. Okay, now that's a SDLC process. What is a server? Server is nothing but it's a physical, it's a machine on which we will be placing our application so that it will be accessible. The application will be accessible to everyone in the world. Okay, that's a server. Okay, now where does Docker and Kubernetes fits in SDLC process? Okay, the Docker and Kubernetes, as I already mentioned, I have it fits in deployment phase in the SDLC process actually, because the way we are going to deploy our application is using Docker and Kubernetes. Okay, that's the thing. Okay, now see, previously what the people did is people used to deploy their applications on the physical servers. Okay, so they face some disadvantages when they deployed their applications on the physical servers. What are the disadvantages they have faced when they deploy their applications on the physical servers? Let's go with that actually. Okay, see here, deploying applications on the physical server actually. Okay, so physical server, you need to first understand what is physical server. Physical server is nothing but it's a server where with which like see, your laptop is a physical server. Okay, so on which you can install the applications, right? So something like that. Okay, so it's a where we can host our applications actually. That's a physical server with which we can touch. Okay, that's a physical server. Okay, now let me write it here. Deploying applications on physical server. Okay, so deploying applications on physical server. Okay, so now what are the disadvantages that we have if we deploy the applications on the physical server? Okay, so let's see that. Okay, suppose this is the physical server that we have. Okay, this is the physical server that we have. Okay, suppose let's think this physical server has some 10 GB of RAM. Okay, 10 GB. Okay, 10 GB RAM. Okay, and mm, and 10 CPUs, 10 CPUs, something like this. Okay, this is a physical server which has 10 GB of RAM and 10 CPUs. Okay, now here we have an application. Okay, this is an application. Okay, so this application, okay, let me label that one as application. Okay, uh app, okay, app. Okay, so this application is deployed on the physical server. Okay, this is an application that is deployed on the physical server. Okay, this is a physical server. Let me label that to make that very clear. Okay, let me put it here, label. Okay, physical is a physical server. Okay, so what is physical server? Physical server is a server where which we can touch and feel. Okay, it's like a your laptop is a physical server. Okay, so now you can see that this is an application. Suppose our application requires some CPU and some memory in order to run on the physical servers. Like so, suppose let's think our application required 1 GB of CPU and 1 1 GB of memory and 1 CPU. Okay, so in order to run your application on this physical server, you this much is required. Okay, 1 GB of RAM and 1 CPU. Okay, so out of this 10 GB of RAM and 10 CPUs, 1 GB of RAM and 1 CPU is allocated. No problem, the application will be properly running. Okay, but if you want to deploy one more application on this physical server, it's you actually it's not possible because physical server we can deploy this application. Okay, one application. If you want to deploy one more application, you need to purchase one more physical server. Okay, so here even though the resources are there for this physical server, even though the resources means CPU and memory. See, 1 GB of memory and 1 CPU is used by this application. What is the remaining CPU and what is the remaining memory? Okay, so 9 CPUs, 9 GB memory, 9 GB RAM. RAM means memory. Okay, so and 9 CPUs are idle and they are left out. Okay, they are idle. Okay, they are unused. Okay, so the main this is the first disadvantage that we have if we deploy our applications on the physical servers. Okay, the first disadvantage if you deploy your applications on the physical servers is the resource wastage. This advantage of deploying applications on physical server. Okay, the first disadvantage that we have if we deploy our applications on physical server is resource wastage. Okay, so you can see that here, out of 10 GB of RAM and 10 CPUs, okay, 1 GB of RAM and 1 CPU is used by my application, and the remaining 9 GB of RAM and 9 CPUs is idle and it's left out like that. Okay, so this is something called resource wastage. Okay, so the first disadvantage that we have if you deploy your applications on the physical servers. Okay, so the second disadvantage, suppose if you want to deploy multiple applications. Okay, if you want to deploy one more application, that is application 2. Okay, so you need to purchase one more physical server. Okay, so there will be a huge cost. Actually, the second disadvantage, if you want to purchase one more physical server, you need to again purchase that one and you need to again afford that one. Okay, so deploying the applications on the physical server will take huge cost, huge cost. Okay, cost. Okay, even though if you have a money and if you have purchased a physical server, okay, so you have purchased and you have deployed the another applications on the second physical server. Okay, so there should be separate team in order to maintain a physical server. Okay, there should be power supply, there should be separate place in order to deploy, in order to put that physical server, right? So this contains huge maintenance. Okay, huge maintenance. That's the third disadvantage that we have if you deploy the applications on the physical server, that is huge maintenance. Okay, these are third disadvantage that we have. Okay, the fourth disadvantage that we have is, suppose there is something happened to this physical server. Okay, there is something happened to this physical server and this physical server got crashed. Okay, so if this physical server got crashed, the application on that physical server is going to be crashed. Okay, because it will not be accessible because the application is running on the physical server which is being crashed, right? So the fourth disadvantage, so there is no high availability. Okay, that means even though in case of virtualization in the cloud, if something happens to that server, automatically a new server will be launched and the application will be automatically launched actually. So here in the case of physical server, there is no what is that no high availability. No high availability is there as part of our physical server. So all these things, there are many disadvantages like this if you keep on talking with actually, but let's stick to this. These are the main disadvantages that we have if you deploy the applications on the physical servers. Okay, first one is resource wastage, second one is huge cost, third one is huge maintenance, and the fourth one is no high availability. Okay, so because of these reasons, because of the disadvantages that we have with the physical servers, that we have if you deploy the applications on the physical servers, what people did, people have migrated to virtualization and the virtual servers. Okay, what is virtualization and what is virtual servers? Now let me help you with the understand. Let me help you with the diagram. Okay, now in the same way how the physical server have this is also a physical server. Let me copy this, control C, control V. Okay, this is also a physical server. Okay, so which contains 10 CPUs and 10 GB of RAM. Okay, something like this which I have mentioned. Let me remove this, which contains 10 GB of RAM and 10 CPUs. This is also a physical server on which we will be having the operating system. Okay, on which we will be having the operating system. Okay, so this might be whatever the operating system might be. Okay, let me write some operating system. Operating system. Okay, on top of this operating system, what people does, people is going to install a virtualization software. Okay, virtualization software. Okay, now what this virtualization software does for us. Okay, so now let me write it that one. Okay, virtualization software. Okay, so virtualization software, it's like it's a virtual box. You people might be installed the virtual box in your local machine. What that virtual box did for us, for you, okay, virtual box, it will be helping you to create multiple machines in your single machine, right? So in the same way, this virtualization that is installed on this physical server will help us to create multiple servers on the same physical server. Okay, this is first server. Okay, now this is second server. Okay, now this is the third server. Okay, what it does, virtualization is a software that will be installed on the physical server with what it gives us the flexibility. It provides us to create multiple servers within the same physical server. Okay, these multiple servers are called virtual servers, virtual machines, or virtual servers, something like this, VMs that we call it as. Okay, these are virtual machines. Okay, virtual machines. Okay, out of this 10 GB RAM and 10 CPUs that is there with this physical server, 3 GB RAM and 3 CPUs will be allocated. 3 GB RAM and 3 CPU will be allocated to each of this virtual server. Okay, let me put it something like this. Okay, like this. Okay, okay, so each out of this 10 GB RAM and 10 CPUs, 3 GB RAM and 3 CPUs will be allocated to all these three each virtual server or the virtual machine. Okay, so the 1 GB remaining 1 GB of RAM and 1 CPU is used by this operating system and the virtualization software. Okay, now, and this physical servers is entirely managed by cloud providers like AWS and the Azure and the Google Cloud. This physical server is entirely managed by them. We are not managing the physical servers if you deal with cloud. Okay, so now see here. Now, if you want to deploy multiple applications, you can deploy one application in this place. Okay, application 2 in this place, something like this, and the application 3 in this place. Okay, something like this. So previously, if we want to deploy multiple applications, we need multiple physical servers. But now in case of virtualization, we are having one physical server, and we are deploying the different multiple applications on the one physical servers using virtualization using virtualization. Okay, instead of purchasing multiple physical servers, we are only purchasing one physical server, right? So I'm deploying our applications, so that removes the huge cost disadvantage that we have with the physical servers. Okay, okay, this huge cost is removed as part of the virtualization, and the huge maintenance is also removed, because if only few physical servers are purchased, there will not be any maintenance, and very less maintenance will be there with when we compare to the deploying applications directly on the physical server. Okay, so in case of virtualization, there will be very less maintenance actually. Okay, that's a this also disadvantages, that this disadvantage is also gone in case of virtualization. Okay, when we deal with cloud, what will happen is these three machines will be part of the auto scaling group. There is something called auto scaling group. Okay, in the cloud, in the AWS actually. Okay, if these three machines are part of auto scaling group, if any one of this machine dies, okay, some problem, okay, if any one of this machine has been killed with some problem, automatically a new machine will be created without we interacting manually, and our application will be deployed, okay, automatically without we doing anything. Okay, so that is high availability that is going to be there as part of this virtualization in the cloud, but not in the case of physical server. Okay, so this disadvantage that we have with the physical server is gone when we deal with cloud and virtualization. Okay, so this high availability disadvantage is gone. Okay, is removed from this place. Okay, now the only disadvantage that we have in case of this one is the resource wastage. Okay, still the resource wastage is there. Okay, if you ask me how it is, because suppose this is an application one. Okay, let me rename it. Okay, now app one, something like that, app one, and app two, and app three. Okay, this is app one, app two, and app three. Okay, now here out of this app one, app two, and app three, let's think this application is using 1 GB of RAM and 1 CPU, and 1 GB of RAM and 1 CPU, something like this. Okay, out of 3 GB of RAM that is there in this virtual machine and 3 CPUs that is there in this virtual machine, 1 GB of RAM and 1 CPU is only being used by the application. Now what about remaining 2 GB of RAM and 2 CPUs? Okay, what about remaining 2 GB of RAM, 2 CPUs? Okay, so that's again the resource wastage that is still there as part of the virtualization. Okay, let me put it here. Remaining CPUs and remaining memory will be 2 GB of CPU and 2 GB of RAM and 2 CPUs. Okay, so 2 GB RAM and 2 CPUs. CPUs actually. Okay, like that. If the application 2 is also using one CPU, 1 GB of RAM and 1 CPU, something like this. Let me copy from here. Okay, let me copy it from here. Okay, if the application 2 is also using the same resources like a 1 GB of RAM, 1 CPU, and the lift out thing is 2 GB of RAM, 2 CPU. Okay, if the application 3 is also using 1 GB of RAM and 1 CPU, the left out thing is 2 GB of RAM and 2 CPUs, like this. Okay, if here in this case also, okay, so the resource wastage is there. Okay, 2 GB of RAM and 2 CPUs, or the resource wastage that is still there as part of this virtualization. Okay, so now because of these reasons, we will be, because of the evolution of microservices and the resource wastage, and there are some reasons, we will be going to Docker. Okay, how the Docker looks like when we installed on the machines actually. Now let me draw that one. Okay, suppose this is the physical machine, this is a physical machine on which we have something like this. Okay, let me select. Okay, 1 second. Okay, this is also physical server which contains 10 GB of RAM and 10 CPUs. On this physical server, we have an operating system. This is an operating system that we have. Okay, so on this top of operating system, we are going to have virtualization software, which is already mentioned. Okay, something like this. And in this what is this virtualization software will help us? Virtualization software will help us to create multiple virtual machines in the same machine. Okay, so same physical machine, see, virtual machine, virtual server, physical machine, physical servers, everything is same. Okay, so we will when it come to AWS, we'll also call that one as EC2 machines. Okay, do not worry about that, all the things are same. Okay, now this is the virtual machine present in this physical machine. Okay, now VM, this is a VM, and which contains 3 GB of RAM, 3 GB of RAM and 3 CPU. Okay, let me move this to left. Okay, 3 CPU. Okay, something like this. Okay, now here let me indicate that with dot something like this, so that you will be understanding there will be a multiple virtual machines as part of this physical machine. Okay, something like this. Okay, now let me label this also. This is an operating system that will be there. Operating system. And on top of this, we will be having the virtualization software. Virtualization software, right? So here, this is a virtual machine. Okay. Now in this virtual machine also, there will be something called operating system, guest operating system that we call it as. There will be something called operating system in each virtual machine. Here also there will be a operating system. Okay. Now operating system. Okay, on top of this operating system, we are going to install Docker. Okay, we are going to install Docker. Okay, so here the physical server is not maintained by us. Physical server is maintained by cloud providers like AWS. Okay, we are not responsible for maintaining it. Okay, so now the operating system. Now on top of this operating system, we are going to install Docker. So what this Docker provides us? What this Docker provides us? Docker will help us to deploy multiple applications in the same virtual machine, so as containers. So what is container? What is Docker image? We are going to see in the future classes in the terminologies of Docker. Do not worry about that. But yeah, now let me put that one here. Suppose this is a Docker container. Okay, now let me copy this one, and we have this is application 2. Okay, this is an application 2, and this is an application 3. I will be labeling that. Do not worry about that here. Okay, now here this is an app 1, this is an app 1, app 1, and this is an app 2, app 2, app 2, and this is an app 3, app 3, something like this. Okay, so here application 1, application 2, and application 3 will be deployed on the same virtual machine or the virtual server. And suppose if this application 1 is been consuming 1 CPU and 1 GB of RAM, something like this. Let me put it here. 1 CPU, 1 CPU, and 1 GB of RAM is consumed by this application. Okay, 1 GB. Okay, 1 GB of RAM and 1 CPU. Okay, something like this. Okay, now let me cut it and paste it there. Okay, let me copy this. Okay. Okay, let me put it this here. Okay, now let me put it this one here. Okay, so application 1, application 2, application 3 is using 1 CPU of 1 GB of RAM, 1 CPU. Application 2 is also 1 GB of RAM, 1 CPU, and application 3 is also 1 GB of RAM and 1 CPU. See, all these three are nothing but a containers. Okay, all these three are nothing but a containers. Okay, here you can see that here out of this 3 GB of RAM and 3 CPUs, all the entire resources like 3 GB of RAM and 3 CPUs were being used by my applications. Like means it's there is no like a resource wastage that is there as part of this. Okay, you can see that very clearly. Okay, as part of this. Okay, this is how visually how we are going to install Docker on the virtual machines actually. Okay, this is how we are going to install Docker on the virtual machines. This is why the Docker is evolved. This is all the problem of virtualization, and this solves the problem of communication between the services during microservices world. Okay, so that's the thing actually. Now after this, you need to understand few things. In the previous times, suppose let's think there is an amazon.com.in application. In this amazon.in application, okay, let me keep a big line here. Okay, so something like this. Okay, in this amazon.in application, suppose this is an amazon.in application. In this amazon.in application, there will be multiple functionalities. Okay, first functionality, let me write, is payment related functionality. Okay, the second functionality that we have is cart. We can add our products to cart, right? So that's a cart functionality. The third functionality that we have is what is that? Clothing. Okay, the fourth functionality is electronics. See, all these multiple functionalities are there as part of this Amazon.in application. Okay, all this in case of in previous like before 10 years or something like that. Okay, this is a monolithic application. Okay, monolithic application. What is monolithic application? Monolithic application is nothing but an application will be developed by combining all the functionalities together as a single application. It is going to be developed actually. Okay, as monolithic application will be developed as a single application. But here in the recent times, this has been there are many disadvantages that we have in case of monolithic application. If you develop all the functionalities together in a single application, there are multiple disadvantages. Okay, so what the people has divided this big application into small applications. These are something called microservices. Okay, something like this. These are one application. Okay, uh, this is another application. Okay, so this is another application that we have, and this is another application that we have. So here, instead of developing all the functionalities in a single monolithic application, people developed individual applications, nothing but a microservices. So each functionality in this monolithic application is developed as a separate application, like payments. These are payments related applications separately developed. But here in this monolithic, okay, all the applications, all the functionalities are developed as a only single application. But here each functionality is developed as a different application. Okay, this is cart. Okay, and this is electronics. And this is clothing. Okay, here what will happen is these are something called microservices, and they will be able to talk to each other using REST APIs. Okay, so they will be able to talk to something like this. Okay, the cart application will be able to talk to payments. Once the item is added to cart, it should do the payment. Okay, and this clothing will also be able to talk to payment, something like this. Okay, so they will be able to they will be able to talking with each other, something like this. Okay, so here individual microservices, here this is one microservice, this other microservice, this other microservice, this other microservice. Okay, so here each microservice is deployed separately, okay, into the server. How it is deployed? Using Docker. Okay, so each microservice is deployed separately onto the server by using Docker. Okay, it is something called Docker container, we call it as, but as we don't know the terminology of Docker, as we have did not learn, we will be learning. Each application will be deployed as a separate application on the servers using Docker. Okay, so like this. Okay, so this is how Docker is also important, but because of the evolution of microservices. Okay, so Docker container. Okay, so this individually deployed as a Docker container, something like this. Okay, Docker. What is Docker container? What is a container actually? We are going to see actually. Do not worry about that. Container. Docker containers. And these also Docker containers. Okay, something like this. Okay, so this is how we will be moving with our course. Actually, for what we have did today, we have seen the introduction parts, what is DevOps and what is application, what is a server, what is a physical server, what is a virtual, what will happen if we deploy our application on the physical server, what is the disadvantage that we have, and how we transition from the from deploying the application of the physical server to the virtual servers, and what are the disadvantages that we have in case of virtual server, and how we transitioned from the virtual server to the Docker, and why we need to use Docker, because it provides the flexibility like that. You can see that it saves the resources for us. And yeah, in case of microservices world, you need to use Docker. Not only Docker, there are like that, like Docker, like there are multiple container runtime engine. Docker is something called container runtime engine. Okay, like that there are multiple container runtime engines available in the market, like container D. Okay, like that. Okay, example is container D we have. Okay, so Docker is a famous tool that you need to learn as part of the microservice in this microservices world, right? So like this we are going to learn in this course, actually, like one by one, something like this. And yeah, that's what we have learned today. And tomorrow we will be seeing how to create an account in the AWS console, and how to connect your AWS console using your local machine, and how to create a server. And we will be seeing Docker, what is that, terminologies. Actually, we are going to see Docker terminology, like what is Docker image, what is Docker container, what is Docker host, what is Docker client, what is Docker registry, what is a Docker daemon, in the Docker registry, what is public Docker registry, what is private Docker registry. All these things we are going to see. Okay, so that's a tomorrow's class. Anyone have any questions today? Anyone? Is that fine? Anyone have any questions? Any questions, please? Am I audible?
Tomorrow means do we have class tomorrow too?
Yes, only this Saturday is there.
The one quick there, you said like tomorrow will be class, right? To confirm it.
Yeah, tomorrow there is class, only this Saturday.
Okay.
Yeah.
So on the like the payment card, clothing, electronics, like you said, monolithic is broken down into microservices like payment card, electronics. So this will be having each of the microservice will have separate Docker file, deploy
Yes.
Docker container.
Yes. Separate Docker file and deployed as a separate Docker container.
So we can deploy all like 4 microservices on the Docker container, one at a time, like all at a time, right? We can
Yeah,
do
we
it.
can deploy the 4 different Docker containers all at a time in single time, actually. Yes, you're right.
Okay.
But as a different applications, not in a single application. Okay. Because they
Okay.
have developed like that only, separate applications. So.
Mhm. So this application, like 4 different microservices, can it be in different programming language and different
Yes, yes. Yes,
environment? Like
yes, that is a flexibility that we are getting if you deal with microservices. Okay, if you are developing as a single application, you need to only choose one programming language for all the different functionalities. But in this case, you can use whatever for payments, you can use Java. For card, you can use .NET. For electronics, you can use Python, or whatever it is. You can use different programming languages because they are communicating with each other using REST APIs. Okay, what? Yeah, that's a flexibility that is being given to you in case of microservices applications.
and then if we need to deploy, like at the end of day, like this, all the microservice application will create the Docker file and then deploy, right? No matter what their programming language is, right?
Yes.
Okay.
And we are going to automate the process of creation of Docker images and deployment also. Okay, in the course.
Okay, great. All right. Yeah, thank you.
Yeah.
I'm good, sir.
Yeah. Thank you. Yeah. Srini, you have joined newly today.
Yes, I have joined just now.
Okay. If you are missing the sessions, okay, these sessions will be uploaded to YouTube, to the DurgaSoft channel. Okay, so you will be having an access to this anyway, so you can view there. Okay, so yeah, is that
Sure.
fine? Okay.
Yeah, fine.
Okay, and please make sure these sessions are going to be shifted to 8 a.m. from 7 a.m. Actually, tomorrow there is a class. Okay, because only this Saturday, from next Saturday we are not going to have. But yeah, I need to match the syllabus between the batches. So that's why, and that's the thing actually. Tomorrow, whatever the things we are going to see, I have already mentioned. Okay, so that's the thing. Okay, yeah,
So
yeah,
tomorrow, and you said like Monday will be also the 7 a.m. or
yeah.
Monday will
Monday,
8 a.m.
no, no. Until and unless I say, uh, it will not shift to 8 a.m. Once I said, it will shift to 8 a.m. Okay.
Okay, okay,
Yeah.
okay, sir. Thank you.
Yeah. Thank you. Thank you. Thanks. Thanks for joining. I'll meet in the next class. Thank you. Bye.